Hey guys, my name is Reno, and today I'm going to be teaching you about inductive and deductive reasoning. Okay, so first off, let's start with inductive reasoning. So, before we go on to that, let's take a look at the definition of a conjecture. A conjecture is an unproven statement that is based on observation. So, you can use inductive reasoning when you find a pattern in specific cases and then write a conjecture for the general case. So, as you can see here, an inductive reasoning is just based on a pattern that we see in specific cases. Then you write a sentence that is based on that or based on that pattern. So this is a conjecture is unproven, unlike the deductive reasoning that we will eventually learn about. Inductive reasoning does not require you to use laws or anything to prove it. It's just based on some patterns. Okay, so example of inductive reasoning. So here you're given three pictures. Describe how to sketch the fourth figure in the pattern, then sketch the figure. Pause the video, give this a shot, come back, and I'll give you the right answer. Okay, so now that you're back, in our first picture, we have a semicircle, and then next one, we have a circle divided into 4 pieces. Next, a circle divided into 6 pieces, and then all of them, just one piece is shaded. So, the answer. As you can see here, there is a pattern. In each of these diagrams, there's 2 more than there were in the previous one. So for example, in the first one there's only 2, next there were 4, and then next there were 6. So all you have to do for the fourth figure is just add 2 more, which gives us 8 pieces, and then shade 1 near the area of the rest. And then here's how it would look like. Here's a circle divided into 8s, and then there's just 1 shaded all the way at the top, near everyone else. Okay, so now, making and testing a conjecture. So, here, this is the practice problem. Numbers such as 6, 7, 8, and 9 are consecutive numbers. Make and test a conjecture about the sum of any 3 consecutive numbers. Pause the video, give this a shot, come back, and I'll give you the right answer. Alright, so now that you're back. So, first, in order to use inductive reasoning and write a conjecture, we need to look at a pattern. So, consecutive numbers 3, 4, and 5 sum up to give us 12, and then here, as we can see, the second number multiplied by 3 gives us our sum. Here's something forming. So 8, 9, and 10 gives us 27, and then 9 times 3 also gives us 27. So as we can see here, there is a pattern, but let's test it out in a few more cases. So numbers 6, 7, 8 give us 21, and then 7 times 3 is equal to 21. And then 1 plus 2 plus 3 is equal to 6. And then if you multiply the second number by 3, we also get 6. So as you can see here, there is a clear pattern. The second number multiplied by 3 will give you the sum of any 3 consecutive numbers. And that's going to be your conjecture. The sum of any 3 consecutive numbers is 3 times the second number. So now to test our conjecture, we're given 3 3-digit numbers, 201, 202, and 203. If we sum all of them up, we get 606. Then we multiply the second number, 202, by 3. We also get 606. 601, 602, and 603 gives us 1806. And then if we multiply the second number, 602, by 3, we get 1806. So, as you can see here, after testing our conjecture, we now know that our conjecture is true. Okay. So now, a counterexample. So, to show that a conjecture is true, you must show that it is true for all cases. You can show that a conjecture is false, however, by finding just one counterexample. A counterexample is a specific case for which the conjecture is false. So you don't need to test out multiple cases to check if the conjecture is true. You do have to do that to check if it is true, but to check if it's false, you don't need to do anything. You just need to find one counterexample, and then there, the conjecture is false. Okay, so now, finding a counterexample. So, a student makes the following conjecture about the sum of 2 numbers. Find a counterexample and disprove the student's conjecture. The conjecture is, the sum of 2 numbers is always more than the greater number. So pause the video, find a counterexample, and then come back and look for the right answer. Okay, so now that you're back, here we have 2 numbers, -4 and -6. When we sum both of them up, we get -10. The sum of these 2 numbers is less than the greater number, which is -4. Therefore, disproving our conjecture, so the sum of these two numbers, -10, is less than the first number or the greater number, -4, thus disproving the conjecture of the student. Okay, so now using deductive reasoning. So deductive reasoning uses facts, definitions, accepted properties, and the laws of logic to form a logical statement. This is different from inductive reasoning, which uses specific examples and patterns to form a conclusion. So, inductive reasoning uses patterns, but deductive reasoning uses facts, definitions, anything that is accepted or true to form a logical statement. Alright, but there's more. Laws of logic. So, as we saw here, and the laws of logic, we don't really know what they are, but now I'm going to talk about them. The law of detachment: if the hypothesis of a true conditional statement is true, then the conclusion is also true. So if the hypothesis of a true conditional, so before we check, if the hypothesis, the if and then, is true, then the hypothesis is also true, then the conclusion also must be true. So next, the law of syllogism. So if hypothesis P, then conclusion Q. If hypothesis Q, then conclusion R. As we can see here, hypothesis P, then conclusion Q. And then we have the same Q here as the hypothesis. Hypothesis Q, then conclusion R. So due to that, we can say, since the conclusion is the hypothesis here, we can say that if hypothesis P, then conclusion R. We'll get into this more in the following examples. Okay, so before we go on to that, using the law of detachment. So, if two segments have the same length, then they are congruent segments. You know that AC is equal to BC. Using the law of detachment, what statement can we make? Pause the video, give this a shot, come back, I'll give you the answer. Alright, so now that you're back, if two segments have the same length, then they are congruent segments. We know that AC is equal to BC. So, since we know that AC is equal to BC, two segments have the same length, so the hypothesis is true, and the law of detachment tells us that if the hypothesis of a true conditional is true, then the conclusion also must be true. This is a true conditional. Since two segments have the same length, then they are congruent segments. This is true. So the conclusion here also must be true, telling us that AC and BC are congruent segments. Okay, so next, using the law of syllogism. Alright, if possible, write a new conditional statement using the law of syllogism that follows from the pair of true statements. So these are both true statements, but try to write a new conditional statement using the law of syllogism. Pause the video, give this a shot, come back, and I'll give you the right answer. Okay, so now, go to the answers. If x squared is greater than 25, then x squared is greater than 20. If x squared is greater than 5, then x squared is greater than 25. So, we need to flip these and put the second one on top and the first one on the bottom. Now, as we can see here, the conclusion of the first one is the hypothesis of the second one. So, and that follows the law of syllogism, telling us that the new conditional is if x is greater than 5, then x squared is greater than 20. Okay, so, but for number B, we can't really write a new conditional statement because none of the conclusions and the hypothesis are the same. So, as you saw earlier, here, if a polygon is regular, then all the interior angles of the polygon are congruent. If a polygon is irregular, then all its sides are congruent. Okay, so as we saw there, none of the conclusions were the same as the hypothesis in the first or the second one, so we can't use the law of syllogism in this situation. Alright, so using inductive and deductive reasoning. So, what conclusion can you make about the product of any even integer and any other integer? Use inductive reasoning to make a conjecture, and then deductive reasoning to prove the conjecture. Pause the video, give this a shot, come back, and I'll give you the right answer. Alright, so now that you're back. So first off, the using inductive reasoning. So we need to make a conclusion about the product of any even integer and any other integer. So first, -2 times -2 gives us an even number. 2 times 1 gives us an even number. This is even and this is odd. 2 times 2 gives us an even number. 3 times 2 also gives us an even number. So as we can see here, any number multiplied by 2 does give us an even number. So any even number multiplied by any integer will result in an even integer. So now, using deductive reasoning to prove it. So let r and t be any integers. So 2r will result in an even number as an answer because it is being multiplied by an even number, 2. 2rt represent the product of even integer 2r and any integer t. So 2rt is the product of 2 and integer rt. So 2rt is the product of 2 and integer rt. Then the product must be even because any integer multiplied by 2 is even, since 2 is an even number. So therefore, our conjecture that we made earlier, any even number multiplied by any integer will result in an even integer. This is true, as proved by deductive reasoning. So if you found this video educational, leave a like, subscribe, and come back for more educational videos like this.